Oh, I don't think you need it, but oh, okay. Okay. Okay, so let's go ahead and go over these two theorems. So the first one is the SSS theorem, or the side-side-side theorem. It's pretty straightforward. It basically says if three sides of one triangle are congruent to three sides of another triangle, well, then those two triangles are congruent. So basically what we're trying to prove in this one, what criteria we're trying to meet, is that all three angles are congruent to each other. Or not really all three angles. I don't want you to confuse it where all three angles have to be congruent to each other, but rather one set of angles or one set of sides are congruent to each other. Side number one is congruent to each other. Side number two is congruent to each other. And side number three is congruent to each other. So if we can prove that each of the three sides are congruent to each of the three sides of the other triangle, well, then those two triangles would be congruent. Pretty straightforward, okay? And so that's what we see here. We see this side is congruent to this side. This side is congruent to this side. And this side is congruent to this side, right? So basically, we can identify that one set of sides is congruent, another set of sides is congruent, and then the last set of sides are congruent. And so all three of my sides are congruent to all three of the other triangle, and so those are congruent. So here's an example we probably might encounter. It says, what value of x would make triangle PQR and STQ true or congruent by the side-side-side theorem, right? And so we know that the side-side-side theorem, what we need to prove is that all of our angles are congruent to each other. So this angle is congruent to this angle. We can see here that obviously this angle is 21. This angle is also 21, so that angle is congruent to that angle. And then lastly, in order to use the side-side-side theorem, we want to prove is that this angle is congruent to this angle. So basically, they have to be the same measure. And so using that, we want to identify what does that x have to be in 3x plus 4 to make it congruent to that other side, 13. Right, so we want to prove that those two sides are congruent to each other in order to use the side-side-side theorem. So what we want to go ahead and do is solve for x. We can plug this into our calculator and solve for x, or we can do it algebraically. If we want to do it algebraically, divide by 4 on both sides. 3x equals 9. Divide by 3 on both sides. X is equal to 3. So when x is equal to 3, that is when both of my side lengths are congruent to each other. And I can double check this. 9 plus 4. 9 plus 4 is 13. And so therefore, this side is in fact congruent to this side, which is what I need to prove in order to make sure that all my sides are congruent to each other. Questions? Questions, concerns? Pretty straightforward, right? All I'm trying to prove is that all my sides are congruent to each other. And if that is the case, then too, both of my triangles are congruent. Last one we're going to look at today is the hypotenuse leg theorem. This one's pretty straightforward. It says that the hypotenuse in a leg of one right triangle are congruent to the hypotenuse in the leg of another right triangle, then those two triangles are congruent. In order to use this theorem, first I want to prove that I have two right triangles. So I want to prove that both of my triangles are right triangles. And that's what this symbol represents to me. So those two are in fact right triangles. Both of those triangles are right triangles. Next, what I want to prove is that my hypotenuses are congruent to each other. Now, whenever you have a right triangle, your hypotenuse is always going to be opposite your right angle. So this will always be your hypotenuse. So I want to prove that those two are congruent to each other. So opposite this right is this one, and opposite this one is this one. And what that symbol tells me is those two are congruent to each other, so therefore both of my hypotenuses are congruent to each other. Like that. Okay? And then lastly, I want to prove that at least one of my legs are congruent to each other. So whenever I have a right triangle, my legs are going to be those other two sides. I have two legs. So those other two sides that are not hypotenuses are my legs. So if any leg, it can be any one of them, is congruent to another leg on the other triangle, then those two triangles are congruent. So this is my leg and this is my leg. Those two are congruent to each other. And so therefore, I can prove that these two triangles are congruent using the hypotenuse leg theorem. So first thing I want to prove is that I have two right triangles. Once I know I have two right triangles, then I know that I want my hypotenuses to be congruent to each other. And then lastly, I want to know that at least one of my legs is congruent. Okay, so here is an example of that. It says, what value of x would make triangle ABC congruent to FGH by the hypotenuse leg theorem? Well, remember the criteria I want to meet. I want to have right triangles. So both have to be right triangles. Then I want my hypotenuse to be congruent. And then lastly, I want at least one leg to be congruent. Okay, so do I have both right triangles? Well, yes, this is a right triangle. And this is a right triangle. Okay. Now I want both of my hypotenuses to be congruent. Remember that my hypotenuses are opposite my right angle. So I want this angle or this side length to be congruent to this side length. So I want to solve for x. So again, you can plug that into your calculator or solve algebraically. X is equal to 4. Okay, so once I know that x is equal to 4, that is what would make both of my hypotenuses true. Now I also want both of my legs to be congruent to each other, or any one of my legs to be congruent to each other. Whichever one I want to choose. It looks like this one and this one. We want to see if I plug in that 4, will I get the same answer? So 2 times 4 plus 1. 8 plus 1 also equals 9. So that tells me that that leg and that leg are in fact congruent to each other. So when x is 4, I'll be able to prove that these two triangles are congruent according to the hypotenuse leg theorem. Okay, questions? Okay. So here's basically these two theorems that we looked at. I have gone ahead and uploaded, and I will show it to you. Kind of a condensed version of what we saw here. That's not what I'm looking for. Here we go. Okay, so here we go. If we click on this, it says side, side, side. And oh, hold on, let me share it again. So I'm not sharing it. There we go. So if you go to the classwork tab, go to Tuesday. Here you'll see a little bit of a condensed version of what we looked at today. So what am I trying to prove? Using the side, side, side theorem, I'm trying to prove that all three of my angles are congruent. Using the hypotenuse leg theorem, I need to prove that I have a right triangle. This is what a right triangle looks like. I need to prove that my hypotenuses are congruent, and then at least one of my legs are congruent. Either it be this leg or this leg, whatever one I want to prove. So those are the criteria I need to meet in order to prove congruence of two triangles using these different theorems. Okay, pretty straightforward. Any questions? We'll go over some practice problems tomorrow, but if there's no other questions, you guys may log off.